is just we're going through some examples, and that's it. Well, he does have paper out, at least he has it. Okay, so my first question, how would you describe what a perfect square is? A number that is a perfect square. Or even what numbers are considered perfect squares. Melcher? 4 is a perfect square. Jacob? 16. 9? Okay. 144? Spencer? 25. Okay, why are all of these numbers perfect squares? Because you're right. I know, it's kind of hard to describe. Faith? Square root is an integer. Oh, I like that. Yes. Perfect squares have a square root that's an integer. Okay, but the way others of you are trying to describe it, it's when you have a number multiplied by itself and it equals 4 or 16 or 25. That makes it a perfect square. It is it's the number, when you take a number and you square it, the number that you get is called a perfect square because, as Faith said, its square root would be an integer. So a perfect square, I'm actually going to add that on here. Has a square root that is an integer. And then I'm just going to list the first 10 perfect squares. So these are not the only perfect squares. I'm just listing the first 10. So, for example, 1 squared is 1. So 1 is a perfect square. This would also mean that the square root of 1 is 1. 2 squared is 4, so 4 is a perfect square. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, and 10 squared is 100. I know, like 144 was thrown out there because that is 12 squared. So obviously there's more. I'm just listing the first 10 because these are the ones you most commonly look for if you're simplifying a radical or simplifying a square root. Okay, and then also to keep in mind when you're simplifying radicals, that you can make this list on your own, like to come up with what numbers are perfect squares, just take the numbers, 1 through 10 or whatever, and just square them to see what your perfect squares are. Guys, can you just put the computer away while we're going through the examples, please? Thank you. Okay, so in case you're still writing those down, I'll leave them, but here's some examples then of simplifying. So that's really all you're practicing today is different square root or radical expressions. How do you simplify those? So here's the first example. Say we have the square root of 18. Okay, 18 is not one of the numbers that we just listed here. It's not a perfect square. If you type in square root of 18 on your calculator, because I changed the modes on your calculators, you should get a decimal. So I'm not asking for a decimal approximation. So this is when you leave your answers in exact form. You're just simplifying this. And this was actually the very last chapter that you did in Algebra 1. So this was chapter 10 that you ended with. So what you are looking for is the number inside. It can only be simplified if the 18 in this case can be divided by a perfect square. Everything can be divided by 1, so you don't really include 1 because that always works. But is there a different perfect square you can divide 18 by? Okay, 9. So I'm going to split this into 18 is 9 times 2. I always list the number that's the perfect square first. So this is 9 times 2. But now, because the 18's in a square root, it's the square root of 9 times the square root of 2. So I'm kind of splitting that square root into two different square roots multiplied together. And the reason I'm doing that is because since 9 is a perfect square, now I can actually take the square root of 9. So the square root of 9 is 3. So this just becomes 3, and then I can't take the square root of 2, so that stays square root of 2. This is your simplified answer. So the square root of 18 in simplest form is 3 square root 2. Okay, but you're splitting it. The numbers that multiply together, one of them has to be a perfect square. So if you can't find a perfect square that goes into it, then it's already simplified. Like 2 is already simplified here. Okay, so let's look at another one. So let's say we had the square root of 24. So you're looking at 24. Is there a perfect square that you can divide 24 by? 4. You can divide 24 by 4. 24 is 4 times 6. So I can split this into the square root of 4 times the square root of 6. What is the square root of 4? 2. And then I still have the square root of 6. And now you should always make sure the square root that I still have left, make sure you can't still simplify that. Is there a perfect square that you can divide 6 by? No, besides 1, but you can divide everything by 1. So then you know in that case it's fully simplified. If I could still simplify the 6, then I should keep going. All right, we'll do another one of these. Square root of 72. So is there a perfect square you can divide 72 by? Kylie? 9. Okay. I know I'm going to go with 9 on purpose. I heard what you said. That's right, too. Okay, because there's multiple perfect squares that go into 72, but I'm glad Kylie said 9. So 72 is 9 times what? 9 times 8. So I'm going to split it into the square root of 9 times the square root of 8. Square root of 9 is 3. And then I have the square root of 8. Then you can simplify the 8 because what goes into 8? 4. So now I would keep going, and I can split the 8. This is 4 times 2, because 4 is a perfect square. I still have this 3 that's in front also. Now the square root of 4 is 2, and what happens is the 3 and then this 2 here, those are going to get multiplied together, and then I still have this square root of 2. So I really have 6 square root of 2 as my final answer. Okay, but Kai, which perfect square were you going to say? 36. So 72, another way to do 72 to get to this answer in one step versus the 2 that we did, you can divide 72 by 36, because that's also a perfect square. It's 36 times 2, and the square root of 36 is 6, and you get to 6 square root 2 right away. So notice you get to the same answer. So that's why you want to try to find the biggest perfect square, but even by not finding the biggest one, as long as you keep going until you can't simplify that radical anymore, just make sure you keep in mind like, oh, I can still simplify that, or nope, I'm done. Okay, questions there? All right, then I just need a different sheet. I'm going to go over if you have a fraction that has a radical in it. So let's say we have, well, I'll do this. Say we have the square root of 7 over 2. So a square root is not simplified if it contains a fraction or a decimal. So when you have a fraction in a square root like this, we can actually split it into the square root of the top and the square root of the bottom. But then, if I look at both of these square roots, let's actually look at this. Is there a perfect square I can divide 7 by? No. And then we already have looked at 2. 2 is already simplified. So both of these square roots are simplified. The problem, though, is you cannot have a square root in a denominator of a fraction. It's just not simplified in math. Anybody remember from last year how you get rid of a square root in the denominator? What did you say, Lily? You multiply by something. So you multiply by the square root that's in your denominator. You multiply it by itself. So I would multiply the square root of 2 by the square root of 2. But then because of my fraction, I also have to multiply the top by the same thing. Because you're really multiplying by, this is equivalent to 1. The same number over itself is 1. So I'm not changing the value of the fraction. It's kind of just the reverse of, like when you have 2 over 4, for example, and you say, well, I'm going to divide both top and bottom by 2 to get 1/2. This is the reverse, where instead of dividing by the same number on the top and bottom, you're multiplying. But you're still not changing the value, you're just making it look different. So on the top, I can multiply these together. So 7 times 2 is 14, so I have the square root of 14. On the bottom, square root of 2 times square root of 2, that would be square root of 4, which is what? 2. So I have square root of 14 over, and my denominator is now just the number 2. So when you multiply a square root by itself, you're making inside of the square root a perfect square so that you can actually take the square root and you no longer have a square root on the bottom. We still have a square root on the top, and that's fine. Is there a perfect square I can divide 14 by? I can divide by 7. Is 7 a perfect square? No. So this is simplified. So this is it. This would be your answer. I cannot divide the 14 with the 2 because the 14 is in a square root, the 2 is not. So I cannot divide the two numbers to get square root of 7 as my answer. So don't do that. We'll just do, well, I'll do a couple more here. This one, say we started with 10 over the square root of 5. Okay, so I don't have a square root on the top. I do have a square root on the bottom. 5, that's simplified. I can't divide 5 by anything besides 5 and 1, and 1 is a perfect square, but it's not going to do anything. So this is where right off the bat I have to just multiply top and bottom by the denominator. So I multiply by the square root of 5 on the top and bottom. Now make sure on the top though, because the 10 is not in a square root and the 5 is, that you're not multiplying these together to get 50. This just stays 10 square root 5. Okay, so there's like a 1 in front of that square root of 5. You're multiplying the 10 and the 1 together, not the 10 and the 5 together. So both numbers have to either not be in a square root or be in a square root. And then on the bottom, square root of 5 times square root of 5 will turn out to be what? Square root of 25, which is 5. So then now, when I look at this, I know the square root of 5 here, I can't do anything with it. But this 10 and 5 that are both not in a square root, those I can simplify. And 10 divided by 5 is 2. So this final answer is just 2 square root of 5. Because if I divide these both by 5, the 10 would become a 2 and the 5 would become a 1. And 2 over 1 is just 2. So this would be your final answer. So I will say any problems in algebra, in math in general, where you're just simplifying can be challenging, because I know there's always that question of like, can I still simplify something? So that's what you're practicing today. We're going to do one more, and then you'll just have time to practice and ask questions. If you had 10 over the square root of 8, so again, 10's not in a square root, 8 is. Can I simplify the square root of 8? Yes. I can split it into what? 4 and 2, so 4 times, or square root of 4 times square root of 2. So it becomes 2 square root of 2. So I'm going to rewrite this. I have 10 over, and my denominator is really 2 square root of 2. Then I know I have a square root on the bottom, but I also have this 10 over 2 here that I can simplify. So if I divide these both by 2, the 10 on top becomes a 5, the 2 on the bottom becomes a 1. So I really have 5 over, and you could keep the 1 there, or that's just the square root of 2. And now, because I still have the square root on the bottom, what do I have to do? Multiply square root of 2 on the top and bottom. So on the top, I will have 5 square root 2 over, what is the bottom going to be? 2, because it'll be the square root of 4, which is just 2. And then here I do have 5 and 2, both not in a square root, but I can't simplify those, so this is my final answer.